Okay, so today we'll look at the time series analysis. Alright, so what is time series data? So actually, time series data is the data which has been observed, alright? We already observed the data, alright? So we already observed the data of a period of time. So the data is observed of a period of time. So the time could be hourly, daily, weekly, monthly, or even yearly. Okay, so usually when we have the historical data, all right, meaning that the data which is in the past, so we can predict the data which will be in the future, right? So the future values can be predicted. So there are four main components of the time series. The first one is trend, all right, this is the first one, and then we have seasonal, all right, and then we have cyclical, and the last one we'll have irregular. Okay, so we'll go through one by one for each component. All right, so the first one, which is the trend, all right, so the trend could be increasing or decreasing depending on the values which can be shown by the histogram, all right. What do we call it that, it will be shown by the upward or downward movement of the time series data, all right. So let's say we have these three types. Okay, so we can see that it is clearly moving upward there, all right. So it is moving upward, something like this. Okay, so this one we call it as increasing, all right. So if it is moving downward, something like this, all right, so it is moving downward, so this is actually decreasing, all right. So if it is something like this, you can't say it is either increasing or either decreasing, so it will be, it will be no trend here. Okay, so there is no trend. It is not decreasing, all right, it is not also increasing, so it will be no trend. So the second component will be the seasonal, all right. So it is also known as the seasonal variation. Okay, so the data series have the repetitive fluctuation, all right. So we have the fluctuation here, so where the fluctuation is in the same pattern, all right. So the features of the fluctuation is the same pattern also. It is because of the seasonal reasons. Okay, so for example, we have higher sales of school uniform during the year end because the school is going to open soon. Okay, and then we have the drop number of customers during office hours because people going to the office for work, so there are not so many customers in the restaurant, in the malls, and so on. All right, so it is only occurs during office hours. This one only occurs during year end. All right, for example, all right, so if you have this, and the fluctuation can already be predicted. Like for example, if we have the if the first one, the second one, the third one, and the fourth one, so during the fourth quarter, and during the first quarter for this one, so will be fluctuated here. All right, so we'll move maybe for the next year, right? First quarter, second quarter, third quarter, and the fourth quarter will be fluctuated here. All right, so every fourth quarter will be fluctuated for this data. All right, so it will be fluctuated here. So the fluctuation can already be predicted every fourth. All right, every fourth time of the data. All right, so the next one, okay, will be cyclical. All right, so the cyclical is actually related to the rise or fall of the data series, all right, over unspecific period of time. All right, so we don't have any specific period of time like in seasonal. Okay, so the fluctuation is usually in a long period. Okay, it's usually in long period and also unpredictable, so we cannot predict like we have done in seasonal. In seasonal we can predict, but in cyclical we cannot predict. All right, so for example, happens in economic recession. Okay, so what happens there? All right, so what happens is that we know that the plot, okay, the plot is allocated around allocated around and also above, so most of them are around and above. Okay, something like this. But from 2011 here, 2011 until 2014, so 2011 until 2014, so between these years, all right, we know that the values are below. Okay, it is below this line, below this red line here. So but all right, it's below here, so but the value is going back. Okay, it's going back to the above the line after 2015 because 2015 is here, right? So it's going back to 2015. So it shows that this data already falls, okay, on a long period because it involves many years, and it cannot be predicted. All right, so one of the examples could be the economic recession, right? And the last one we have the irregular. All right, so in irregular component we have the movement of data series. Okay, we have the movement of data series which are completely unpredictable, so we cannot predict the movement is either increasing or decreasing. It is not repetitive, all right, and it has no definite pattern, so there's no definite pattern. This happens due to abnormality or unusual events. All right, for example, we have natural disaster, we have war, we have policy change, so this happens. Okay, for example, we have increase of groceries price during flood. Okay, another one will be the drop ticket sales after MH370 tragedy. Okay, something like that. Okay, so for example, if you have this type of graph, so they don't have a regular pattern, but it suddenly drops here. Okay, suddenly drops and it's going back to normal. Okay, okay, so this is called as irregular. So the next thing that we're going to see is example 5.2. All right, we try to to see example 5.2. Okay, we have this example. All right, so they asked us to identify the components. So firstly, we look at this plot. We note that it is actually generally downwards movement, meaning that it has decreasing trend because it is moving downward. So it is decreasing trend, all right, decreasing trend. All right, so that's the first one for the trend. And then fluctuations, we know that the fluctuations occurs regularly for each week, and it occurs on the fifth day. It falls on the fifth day. All right, this one, and every on the fifth day. All right, something like this. Okay. So the fluctuations are regular for each week. Highest values during the first day. Okay, highest values during the first day of the week. Right. Then this is the first day of the week. Okay. So of course this is the fifth day of the second week. Okay, and then you have the end of first weeks there. Okay, and then the starting is highest value for the first week, and of course this lowest value during the third week. Okay, so the fifth day. All right. So this one is the end of the third week, and then we have the highest value on the first day of the fourth week, and we have the lowest value on the fifth day. Yeah. Okay, so this is the end of the fourth week. Okay, we know that this is you can see this pattern, so we call this pattern as seasonal. All right, so seasonal pattern. All right, where it has the highest value on the first day of the week but the lowest value on the fifth day of the week. So the next one is that we can look at the plot, okay, on day 6. So look at day 6. Sorry, okay, look at day 6. Day 6 on the second week. All right, so meaning to say this is the first 2, 3, 4, 5, 6. So this is day 6 of the second week, which is, it shows abnormality there. All right, so this is called as irregular. All right, because it suddenly fluctuates there. So this one is irregular. Okay, irregular. And then the components, so we can say that it occurs only once. Okay, not for a long period of time, so that's why it's not cyclical. Okay, so we can say that the components involving are decreasing trend. All right, the first one. Second one is the seasonal pattern, and also the next one is the regular component. So that's how you analyze the plot. Okay. So the next thing that we are going to see is that the time series model. All right, so we have two types of time series model. So the first one will be the additive model, so which is the formulas given by y equal to t plus c plus s plus I, which is the trend plus the cyclical plus the seasonal plus the irregular. The second model will be the multiplicative model. All right, so that one is additive, where in multiplicative model they are related by the multiplication operation there. So it will be multiplied t multiplied by c multiplied by s multiplied by I. But we can modify this multiplicative model. So we modify it to become, because the cyclical and irregular component cannot be isolated because the occurrence is unpredictable. These two, cyclical and also irregular, are unpredictable. So that's why we modify it to have the y equal to t multiplied by s. So in time series model, so we have 3 steps. The first one is the trend analysis. Okay, the next one is seasonal variations, this is the first one. This is the second one, and the last one will be forecasting. So this will be the last step that we're going to do. All right, so to do this, let's look at example. Okay, so we have example, okay, 5.3, I guess. All right, so example 5.3. All right, where in this time series forecasting, we are focusing on the odd period moving average. Meaning odd period, meaning that we have, in this case, we have morning, afternoon, and evening. So there are 3. All right, if it is 4, so it will be even periods. Okay, so in this case, we have this set of data. Okay. Okay, so what we're going to do that the first step, which is the trend analysis. Okay, in trend analysis, we will have to build this table. Okay, so for the first step, we'll have to build this table. You reconstruct the table and write in from something like this. All right, and for Monday, you will have morning, afternoon, evening. So for Tuesday, we'll make the same. So Monday, afternoon, and evening. For Wednesday, we'll do the same. Okay, so the next one, you're going to fill in the table. Okay, so this one, the actual, meaning that all these values, 124, 107, 40, 80. So you list down there. Okay, something like that. Alright, so the next one is that you have to add them up. Meaning to say, you'll have to add, okay, 124, 107, and 80. You add them up, and then you'll have to sum this. Alright, so it will become 311. So for the next table, for the next row, will be 107, 80, and 127. So you'll have to add them up, will get 314. Okay, so the next step, 80 plus 127 plus 96. So you will get 303. And you proceed. So for the next step, so you'll fill up this table with 308. Next one will be 314, 316, and then you'll have 310, you'll have 307, okay, and then you have 312 and also 315, okay. something like this. All right, so usually for this odd moving average, okay, all right, so we have to leave this row blank. Okay, all right, so the next one we are going to find the trend. So how to find the trend? So we have this value, all right, so we have to divide by 3, meaning we have to find the average, because we already add this 3 and then we get 311, and then you have to find the average. So to find the average, so you will have to divide by 3. So 311 divided by 3, you'll get, okay, usually we'll leave as 4 decimal places, 6667, and then for the next one, 314 divided by 3, so you'll have, okay, 104.6667. So you will have the next one 101. Okay, you use your calculator, right? So 102.6667, and then you'll have 104.6667, and then you'll have 105.3333. Please round off to 4 decimal places, and then you have 103.3333, and you have 102.3333, and the next one 104, and the last one will be 105. Okay, you have 1315 divided by 3, you get 105. All right, so for the seasonal variation column, you just leave that for the second step. Okay, right, so we are done with the first step. So we have got the 1 2 3 4 5 6 7 8 9 and 10. So there are 10 trends we have got from this from the actual values. All right, so we are moving to the second step, where we have to estimate the seasonal variation. All right, so meaning to say that we have to find using this formula, where formula for seasonal variation is given by actual value divided by trend, and then we have to multiply by 100. So in this case, we'll have to, okay, let me use green color. You have to actual value, which is 107, you divide with 103.6667, so you'll get the seasonal variation. So in that case, all right, so you'll get 103.2154. Okay, so you'll have to do for the next one, which is 80 divided by 104.667, so you'll get 76, sorry. Okay, 76.4331. For the next step, 127 divided by this 101, so you'll get 125.7426, and then you have to repeat the same thing, actual divide by trend, and then multiply by 100, so you'll get the next one, which is 93.5065. So the next one will be 81.2102, and then you'll have 126.2659. Okay, please use your calculator, and then you have 94.8387, and then you'll have 77.1987, and then you have 125.0000, and your last one you'll have 98.0952. Okay, and then only we can move to the last step. Okay, in the last step, all right, so what we need to do is before we move to the last step, we still have to find the seasonal indices. All right, so after moving the seasonal variations, okay, so note that we have got the seasonal variations starting from Monday afternoon. All right, so which is this value, so we'll have to fill up this table with these values, okay, with all these values. Yeah, right, so we start with 103.2154. okay, 103.2154. Why don't you start with morning? Because at the morning column, at a morning row, you don't have any data. Yeah, all right, so this is morning, right, so you don't have, so that one is, we have no data. For the same goes to the Thursday evening. All right, so you fill up with the next value, which is 76.4331. okay, so it will be 76.4331. all right, so the next one will be, please copy from the previous table, 125.7426. okay, and then you have 93.5065, and then you have 81.2102, and then you'll have 126.2659, and then you have 94.8387, and then you'll have 77.1987. okay, so the next one will be 125. okay, and the last one will be 98.0952. all right, so after completing this table, we'll have to find the total. To find the total, we'll have to add this up. all right, so please use your calculator and add those values, so we'll get 377.0085. Same goes to this one, you have to add these 4 values, so you'll get 389.6558, and the next one we'll add these values, so you'll get 234.9 234.842. Okay, after finding the total, after calculating the total, you'll have to find the mean, alright? Meaning that these values, okay, this value, you have to divide by 3 because you have 3 values here, 1, 2, 3. So you divide by 3, so you'll get 125.6695. So for these values, you have to divide by 4. 1, 2, 3, 4. So to find the mean, you have to divide by 4. Mean is the average. So you get 97.4140. And the last one, you'll have to divide this value with 1, 2, 3. So divide by 3, you get 78.2807. Okay, please take note that you have to total this one. All right, you have to total the 125. All right, 125.6695, 97.4140, and 78.2807. You'll have the actual total. You'll get the actual total. So actual total will be given by 301.3641. all right, so the next thing, all right, sorry for this. So the next thing that we have to find is actually the, what do we call that, correction factor, right? So in this case, the formula will be given by the required total divided by actual total. But in this case, do you know the required total? The required total will be here. All right, so actually the required total is the whole number which is close to this one. All right, so in this case, actually required total will be 300. All right, so find a number, a proper number which is close to that 301. So it will be 300. So you will have, for what do we call that, correction factor. So we'll have the 300. We have 300 divide by 301.3641. That one is correlation factors, yeah. And then we will have the last step. We can find the seasonal indices. Where to find the seasonal indices, you'll have to multiply mean by. You multiply these two. All right. So mean by CF. So you multiply these values, so you'll get this. All right. So you actually get 125.1007. So the next one, 97.14140. So you'll get these values, which is given by 96.9730. And the last one, these values, multiply that one, will get, all right, so you get 77.9263. Please take note that if you add these three values, you'll get 300. All right, if you don't believe, so you should try pressing your calculator. So there are actually meaning, all right, behind these seasonal indices values. And if you have this 125.1007, it means that the number of tires, in this case, we are talking about the number of tires produced. So the number of tires produced are actually 25.1007% above the trend line. While this one, which is below 100, so we have to know how much it is below 100. So we have to press your calculator, 100 minus this value, all right? So you'll get actually 3.03% below the trend line. So the tires produced are 3.03 below the trend line. And the last one, this one also below 100. So how much is it below 100? So we'll know that you have to press your calculator, you'll get 22.07% below the trend line if the questions ask you to interpret the values, okay? All right, so we are now so we know that the seasonal indices for morning will be 125.1007. For afternoon will be 96.9730. For evening will be 77.9263. Because we'll be using this in the last step, which is to find for the forecasting. All right, so for the first step, okay, like for example, in this case, predict the number of tires produced. So this is the question, okay? Asking you to produce number of tires to find the number of tires produced on the Friday afternoon. All right. So we know that our data was only up to Thursday evening, but the next question asking you to find on the Friday. Okay, you have morning, afternoon. So what is the values here? All right, something like this. So firstly, you will have to find the average increase in trend, which is given by the formula last trend multiplied by minus first trend over n minus 1. N is the number of trend. Right, so the last trend in this case, okay, you look at this table. So your last trend will be this 105 and the first trend will be 103.6667. So you insert into this formula. All right, so you will have 105 minus 103.6667 divided by n. N is the number of trends. So how many trends we have already counted just now? We have 10 trends here. All right, so there are 10 trends here. So it will be n will be 10. So over 10 minus 1. So press your calculator and you will get 0.1481. Right, so that one is the average increase in trend. So the next step is the second step, which is to find the forecasted trend value. Right, this table is you can obtain from your previous trend table. All right, this is trend for the last Thursday afternoon, all right? So we are going to find, all right, so on the Friday afternoon. So please highlight from this table where it is Friday afternoon. So meaning to say that we want to find, to focus on this, all right? So this one is the actual data, so which is given by the table here. Or for example, 82 is the last day, all right? This one is 82, and the last trend is here, all right, on 105. That's why it's 105 here. Okay, so to find this, you have to find the number of steps ahead, meaning to say, to get to Friday afternoon, how many steps do we need to go? So you can count 1, 2, and 3, all right? So meaning that you have 3 steps ahead. So you have the last trend. So the last trend, which is given by 105. So 105 plus number of steps ahead, this one, all right? So we have 3 steps ahead plus 3. And then you have to multiply by average increase in trend. We have calculated in the first step just now. So we get 0.1481, all right? So 0.1481. So press your calculator. So you'll definitely get 105.4443, all right? So that one is the forecasted trend, okay, for the Friday afternoon. So the next one, which is the last step, which is to find the forecasted, which is given by the trend multiplied by the seasonal indices divided by 100. So the trend we have got here, okay, 105.4443, you multiply by seasonal indices. Now we are forecasting for afternoon, so you'll have to find the seasonal indices for afternoon, which is given by this one, afternoon, of course, this one, right? So 96.9730, okay, 96.9730. So you have to insert here 96.9730. You divide by 100, so you will get 102.2525. So what can you say? So this is your last answer. So the question is asking you to find the number, to predict the number of tires produced. So of course the numbers of tires produced on Friday afternoon is given by 102.2525. So we are done with this question.